Yeah, I think we may as well just kick it off then. Obviously, the starting point was 6 o'clock, but there's always a few stagglers. So, yeah, firstly, obviously, just to run through a bit of an introduction from me. I'm Jordan. I'm one of the organisers at Trusted Tech Talks. I want to obviously firstly thank all you guys for attending the React Fiber webinar. Hopefully, you find it insightful. I mean, with a lack of opportunities at the moment to go to tech events, tech talks, webinars are a great tool for us just to kind of give back to you guys and give back to the tech community. The way the webinar is going to be broken down, the first 30 minutes, Kannan's obviously going to be speaking a bit more about React Fiber and crossing everything off in that sense. Then after that, we're probably going to have about 15 to 20 minutes for a Q&A at the end. I believe Beth has just put a message in the group. We're going to use Slido. Not sure if anybody's used it or not before, but it's a bit more convenient for everybody. But the link is in the chat. I noticed it's just sli.do, and the web link code is 72423. So the way it kind of works is the more questions that are asked, so people throw out a couple of questions, as opposed to everybody kind of asking the same questions, the more likes that you give a particular question, that will raise to the top of the questions list. Yeah, a bit more convenient as well. But without further delay, I'm going to pass it across to Kannan just to jump in and take it away. But yeah, thanks, Kannan, for running this. Really appreciate it.
Thanks, Jordan.
No problem.
So, let me share my screen. Are you able to see my screen?
Yep.
Hello all. I hope everyone is safe and healthy. This is Kannan Ganesan, Senior Front-End Developer at Simply Business. I do have close to 11 years of experience in front-end development with various sectors such as e-commerce, financial and insurance, etc. So today we are going to talk about React Fiber. And we are going to do a deep dive into React's new architecture called Fiber. And we are going to learn about two main phases of this new reconciliation algorithm. So we need to understand what is reconciliation. If we understand what is reconciliation, then we'll be able to easily understand what our React team does on top of Fiber. So what is reconciliation? Reconciliation is an algorithm React uses to diff one tree with another to determine which parts need to be changed. So basically, this is an algorithm that is used to diff one tree with another. The tree we can say like virtual DOM tree. Virtual DOM is a tree of immutable React elements written from our render method. So each and every functional component or class-based component, we used to have the render method. So in this render method, we are going to return certain elements, right? So those elements will be converted as a virtual DOM. So which I'll explain in the further slides, you can see that. So this is a visual representation of how this virtual DOM happens. So here you can see there's a change happen in the model. Model denotes the current state of my component. So when an action triggers, such as I'm going to trigger set state. So when I do that action, what React does is it creates a virtual DOM, which is a dirty virtual DOM, and it will compare that with the initial virtual DOM, which a previous state of my virtual DOM. And it will find out what is exactly changed using reconciliation algorithm, and it will update the necessary DOM rather than updating the whole tree. So this is one of the main advantage, one of the highlighting feature that React brings us to us. This is the main reason which we migrated from JavaScript to React. Let's take a recap. Before jumping into Fiber, we need to understand, we need to know what was there before and why React built this React Fiber on top of now. So let's take a quick recap. Virtual DOM, as I mentioned, is a tree of React element written from render method. Besides the tree of React element, React has always had a tree of internal instances. I would say like components, DOM nodes, that is mainly used to keep the state. So starting from React 16, React rolled out a new implementation of this internal instance tree, such as components and DOM nodes. and algorithm that manages the code. We used to call this as fiber. We are going to see detailed in the upcoming slides. So before jumping into React Fiber, we need to know how JavaScript executed before, the reason why we need React, and after now why we need React Fiber. So let's take a quick recap on how browser execute JavaScript code. So let's take this visual representation of a two-person. This visual representation is going to be used in upcoming slides. So if you see here your code, this is a code that we are going to write. And this previously JavaScript, how it executes is whatever code that I write will be directly executed to the main thread. There is no intermediate person which will convert your code to do some efficient algorithm or anything. So let's say if you put console.log, that will be directly executed in your browser. So there is no intermediate layer previously. So this is where the problem starts. Using jQuery or JavaScript, any changes, you need to re-render the whole DOM, because main thread will directly re-render the whole DOM, and it will not do any scheduling and other things. So to overcome this kind of problem, React came into a middle place, a kind of a middleman, which will get your code and it will do the virtual DOM calculation and diffing, reconciliation, and it will only update the necessary DOMs in the with the help of main thread. So what React does here is it will do the updates in an efficient manner rather than re-rendering the whole DOM tree, which we did previously using JavaScript. React makes our life much more simpler. Without re-rendering the whole tree, I can only re-render a specific changed portion. So this is what React does. This is a visual representation of how this React is executing. When a tweet happens, the payload will flow and it will come to the, hold on. My system got stuck, sorry. So when a tweet happen, you can see the virtual DOM diff, how it does. It has a old tree and a new tree, and it will compare this both, and it will find out what was changed, and only changed portion will be updated in the browser DOM. So previously there is no, previously in JavaScript, we don't have this kind of two different calculation. Whatever changes, that will directly impact the DOM. But after React, you can see this calculation, which is on top of virtual DOM, it does, and it will change only necessary tree of elements. It will change and it will update the same in the UI, which is a much more enhanced way with the current React that we have right now. So that is the main reason we moved from JavaScript to React. So it does gives us the wonderful way of, hold on, I think my system, hold on. Yes, sorry. Hold on. Yes. So as we have seen, like React does many things, but why React team is still finding out a better solution to improve their current capabilities? The reason is current React that we are currently utilizing has a problem. So what kind of problem does it have? It has a problem. It always depends on recursion to update a child component and re-render each call if necessary. Let's take an example. Like when I trigger an update, set state will trigger an update. Let's say the recursion starts and it cannot be stopped in the middle of process. I mean, once it started, it will not stop, and it will need to scan from the top from the top to bottom of the tree. It need to scan and it need to update, which is a recursion stuff. So it will not be stopped in the middle, which obviously cause side effects like manipulation DOM, and other things will not happen immediately. It needs to wait until the recursion stops. So this results a user experience suffers because everything is waiting for the update to finish. This will obviously cause CPU inefficient, and things like DOM events, animations would be much more laggy. I'll show an example for this. So as in this slide, you can see the main problem is regression logic that React currently uses. So React found this problem, and they wanted to improve the current React core algorithm. That is where Fiber comes in place. You can see the next slide. So using the stack reconciliation, you can see the main thread got struck. The reason is the current React will call mount component and update component on the DOM until it goes to the bottom of the tree using recursive call stack. The reason is it needs to scan, like I have like 10 to 20 components, then I need to recursively go from first component to 10th component, which will hold the main thread. So you can see main thread got struck and it will not proceed further. So the next priority task will not get executed. That is a main problem. So your main thread will get stuck. So this is a simple example of how call stack works. As we have seen, a recursive call stack is a main problem with React. Call stack is something like the function definitions will be pushed into a FIFO model, like all the function definitions will be a part of stack. So during this execution, main thread will get blocked and it will not be released. That is a main problem. So as we are all aware, like JavaScript single threaded, with a single thread in a synchronous way, it will not be able to execute all the definitions at a single shot. But the problem is it will be the main thread will get holded and it will not be released until all the updates gets success. So as you can see here, hold on. Oops. Yeah. System is getting stuck. Hold on. So yeah, so as I mentioned, due to the recursion, main thread got blocked and it's not released, which will cause plenty of efficiency problem while rendering. So that is where Fiber helps us to improve these kind of problems. So let's take this particular animation. For animation, you can see the differences. How current stack, hold on, oh, I have a problem. Yes. So you can see the differences, like current stack, which is current React, and current Fiber. You can see the way of responsiveness of your current algorithm. Stack has a problem with laggy stuffs. When you maximize and minimize, you are doing two different updates in this particular component. You can see this is a triangle where you can have each dot represent each component. This component has doing two different tasks. One is updating the count inside the component, and also it is updating its width and height. So there are two different tasks that is currently doing. So as we have seen, recursive will obviously hold the main thread. That is why we are seeing this jaggy kind of things in the stack. You can see it's getting stuck. It's kind of it's not a proper way. It's not a proper user experience while doing this kind of animation. It's not only impacting animation kind of things, it also impacts an application, which I'll show in the upcoming slides. So in the Fiber, you can see it's smoothly it can able to handle, because it has the Fiber algorithm, which I'm going to explain. So what is React Fiber? React Fiber is a re-implementation of React Core. So basically, as I mentioned, recursion is one of the major disadvantage with React. Fiber, it improves the current efficiency of recursive logic in a different algorithm. Basically, it utilizes a different algorithm to process the tree, processes children, which we are going to see in the upcoming slide. So this is a 2 years effort of React team, where they have gone through plenty of struggles and plenty of R&D on top of finding these kind of advanced version of Fiber. This is much more useful for us to improve our efficiency of applications. So what is Fiber? Fiber is, it has a project management skills. It has an ability to minimize and batch the DOM changes. It also has an ability to keep track of time changed, enabling higher efficiency by the main thread. So basically what it does is it has a project management skills, like what actually project management does. It will give a certain task to one person rather than giving multiple tasks to one person. So as we have one thread, we need to find out an efficient way to manipulate the thread. So that is what this Fiber does. So what it does is without disturbing the main thread. It doing all kind of computation of the componentry. Once the computation has been completed, then it gives the updates in a chunk of piece of data. Rather than giving a one chunk of work, it will split that work into multiple pieces of work, and it will share that to the main thread. I'll show it in the upcoming slides. So what are the differences between current React and React Fiber? You can see the main differences is the way it processing an element, the way it walk through this element, and the way it update the element. So basically this is the main key area of where the Fiber did the changes. So basically Fiber algorithm have changed in these three areas, which we are going to see. The first one is processing an elements. As we are aware, like, this is a simple component that I have taken as an example. This is a click counter component. It returns a button and span. You can see here. So basically when an update happens, it does different activities. So there are various activities React performs during this reconciliation. Some of the high level operations are update count property in the state of click counter, retrieves the component children of click counter and their props, and updating props of the span element. So these are the high level activities. So there are, this is only a high level. There are other activities also performed during this reconciliation, such as life cycle methods, updating refs. All these activities are collectively referred as work. So in the Fiber architecture, in the upcoming slides, you will be referred as work. So work is something like what a component does, like updating a reference or updating a life cycle or updating internal state. So these will be called as a work. So keep a reference for that, because I'm going to talk about work in the upcoming slides. So here the render method returns a two element. From the render method, I have a two element, and that elements will be goes through JSX, and it will end up returning two different methods. So basically, this is a two different method. It will not return HTML like what we usually seen in HTML. So you can see it returns a React.create element with a button, which is a button, and a React.create element as span, with the properties that we are passing will be passed to a React.create element. I'm going to explain how this React.create element does. So once the React.create element receives these properties, it creates a data structure. So this is the key part. The current React also does the same. I'll show what is the difference between Fiber and React in the next slide. So you can see this React.create element will return two data structure. So it has a type of, and it has a type which is the nature of my element, and it has a unique key, and it also has a properties such as children and the method which is binded to it, and other information about the elements that we are returning through a render. So once the element is being returned from the render, it will be merged into a tree of Fiber nodes. So basically, whatever returned from the render method, Fiber will analyze the data, and it will insert its own node. So basically, this node will be the key part for Fiber to do an iteration, or this is a key part that holds the memory or all the necessary properties that it can use in further. So you can see it as a state node. We can say this property is used to hold the local state associated with the Fiber, and it has a type. You can call this as it defines a function or a class associated with a Fiber. For class component, it points to the constructor function, and for the DOM elements, it specifies the HTML tag. So, and then we can see a key. It's a unique identifier with group of children to help React to figure out which item has changed, and it has a memorized state, a pending props, a memorized props. This has its own kind of needs. So let's say this memorized state will have a state of Fiber that that was used to create the output. When processing an update, it reflects the state that currently rendered in the screen. So basically, this has the previous state of your component. So as we have seen, fiber will keep a memory of what happens previously and what is going to be happen future. So it has a two memory, as this is going to be a data structure. It's a new data structure, which I'll explain in the upcoming slides. So it basically it will inject a new parameters such as pending props, memorized props, memorized states. This will be the key part for fiber to understand what is going to happen next. And the tag is one of a key parameter. It defines the type of fiber. In our application, the property tag for click counter component 1, which denotes the class component, and 5 denotes the HTML component, which is span, which we have. So each and every element that we are returning from the render has its own unique tag. This tag will be utilized by fiber nodes. This is used to determine what has changed, and basically this is mainly used for assigning a priority, which I'll explain in the upcoming slides. So we have seen how fiber is processing the elements and creating fiber nodes. You can see what we have seen is how the render returning a two element, and on top of the returned data structure, how fiber is inserting or adding their own properties and creating a new data structure based on the returned React elements. So now we are going to see how React is walking through these elements without regression. As we have seen, there is a main problem with our current React, which is a regression. So we are going to see how React is walking through these three without regression. For that, we can see it uses a linked list tree traversal algorithm. This is the algorithm that Fiber currently uses. All Fiber nodes are currently connected through a linked list using the following properties. You can see a child, sibling, a return. You can think of Fiber as a data structure that represent some work to do, or in other words, a unit of work. As I mentioned previously, work is something happened inside the component, such as updating a ref, or updating a life cycle, or updating component information. Those will be called as work. So as I mentioned, you can think as a Fiber as a data structure, which has its own properties inside. And Fiber architecture also provides a convenient way to track, schedule, pass, and abort the work. This is one of the key part, because using this linked list data structure, Fiber is easily manipulate the DOM, and it can easily goes from one particular component to another particular component, and it can easily manipulate the components. That is one of the key part with the Fibers. So as you have seen, the difference is stack, which is what we have currently. It has a synchronous recursive model that relied on browser built-in stack. So this uses stack, which is our current React, which we are using 15 and below. 16 has a Fiber kind of asynchronous model with a linked list and pointers. So linked list is pointers, one of the key part for us to determine how to travel between components without impacting. So I'll explain the upcoming slides, which will make you much more clear. So as we have seen, every React element that has corresponding Fiber nodes. Unlike React elements, Fiber aren't recreated on every re-render. As we have seen, from the render method, React will return a data structure, and Fiber will add the nodes, right? So this will not happen each and every re-render. This will happen at least only once. After that, a subsequent changes or any changes happen, then the Fiber will recreate. Otherwise, it will not recreate on each and every re-render. So these are a mutable data structure that holds component state and DOM. You can see for the click counter example that I have shown, it has a it has a button and span. The relationship you can see, the child of host root is click counter, and the child is button. And the way it returns, you can see. I'll explain in the next slide how this travel happens. So in this slide, you can see the relationship between how the relationship is getting built on Fiber. Yes. So this is where the execution of the Fiber nodes traveling between components to do an update faster. So you can see fiber tree effects to update text of the span node and call hooks on the click counter. So you can see from the root, it goes to the span first and then it goes to the parent. So this is where the effect starts. You can see the first effect will go to the span, the second effect will go to the click counter. This is happening on top of the linked list structure. As I have shown it, it's using singly linked list. So it is basically, it is try to do like this. The first effect always on the children, second effect goes to the parent. So this is how it builds the linear list of nodes, and this is how it builds the relationship between parent and child, the way it iterates. So let's take this example. This is a it's kind of a simple example of how singly linked list works. This is not related to an example that I have shown. This is how singly linked list approach works. So you can see this is a parent and it has a children. B1 children doesn't have any, P1 doesn't have any children, whereas B2 has a C1, B3 has a C2. So you can see when an update starts from here, it goes to the children. It updates the children first and then it goes to the parent. You can see. So this is how the travel of linked list currently happening. You can see so it has a four main functionality what React does using on top of singly linked list, which is perform a unit of work. It receives a fiber node from the work in progress tree and starts the work by calling begin work function. Begin work is a next function. It always returns a pointer to the next child to process in a loop or null. Complete unit of work. Once the node is completed, it will perform work for sibling and backtrack to the parent after that. You can see the backtrack is how it's happening. So it will go to, once the update is completed, it also has a pointer that will go back to the parent one by one. So the reason why React Fiber, React, they have decided to use singly linked list is it provides very fast insertion and deletion of the elements, and each linked list contains a pointer to the next element in the list. So basically using linked list, we will never wastage the memory. So for memory efficiency, React utilize this singly linked list. As we all aware, reconciliation is something like happening on the memory. It's not happening on the DOM. So they are trying to find out a way to improve the memory. So for that they have choose linked list. So as I mentioned, insertion, deletion, updation is much more faster in linked list, and also it doesn't have any memory wastage. So this is the main reason why React team chosen Fiber for this particular algorithm, linked list tree traversal. So once we all now aware of how the tree is being constructed. There are two different tree currently Fiber has. One is current tree, second one is work in progress tree. After the first render, React sends up with a Fiber tree that reflects the state of application that was used to render the UI. So this is the initial state of my current tree, whereas work in progress tree is something when React starts working on the updates, it's built as so-called work in progress tree that reflects future state to be fleshed on the screen. So basically it's a work. So basically the name itself gives us a view, like there are some work is going on that on the tree that we used to call as work in progress tree, whereas current tree is what it is currently rendered in the UI will have a copy. So in this representation, you'll be able to understand. So this is a current state of my tree, whereas work in progress tree has a pointer which can refer to my children's from top to bottom. So this is one of the major advantage. So as I mentioned, the algorithm goes through, the linked list algorithm will happen only on the work in progress tree in order to travel and find out what is changed and what, once these changes are computed using linked list tree, the corresponding update will happen to the current tree. So that I'll explain the next slide. So as we have seen how Fiber is processing an elements by creating a Fiber nodes, and also we have seen how Fiber is walking these tree of elements without regression using linked list. And now we are going to see how it executes an update or effect, how the changes is reflecting in the DOM. So basically, Fiber doing this on top of two different phases. One is a reconcile phase, second one is commit phase. In the reconcile phase, Fiber node marked with side effect. Whatever the changes that needs to be done will be marked, and it will be the update will be on the work in progress tree, which will happen on the reconcile phase. So building up the work in progress tree using linked list and figuring out the list of changes, but not actually performing them changes yet. This phase, basically during this reconcile phase, this phase can be interrupted to let browser main thread to do its work with the help of a relatively new browser API called a request ideal callback. So basically, this is an API that currently browser has, and using this particular API from JavaScript, from the React point of view, we can find out when the main thread free. At that time, I can give an update to the main thread to do certain tasks. So that is one of the main advantage. So it also has an ability to split interruptible work in chunks. So it also has this kind of ability. This allows the main thread to notify when React has its spare time. So as we have seen, main thread. So the main problem is we are blocking the main thread. So in this case, during this reconcile phase, we are not going to block the main thread. We are going to do this kind of calculation in offline, which will not be which we will not hold the main thread, and we'll do whatever things we want in an asynchronous manner. So as I've shown, like request ideal callback is something on the browser inbuilt. So you can see basically React will request main thread whether do we have enough time. Using the method, we can able to get the time from the request ideal callback method. So it will return a certain time, like if 13 milliseconds or whatever time it will return. So based on the returned milliseconds, React will do the necessary updates. So how does React do this update? So basically, React will split the task into a interruptible work in chunks. So basically, React will have a bunch of work. That bunch of work will not be handed over directly to main thread. It will split that into n number of chunks, and after the n number of chunks, it will prioritize those chunks from like no work. There is no work pending. Synchronous priority will be for control textbook side effect means synchronous side effects. Task priority is something like complete at the end of current tick. Animation priority, which needs to be completed before the next frame. High priority, an interaction that needs to complete pretty soon so that it will be feel responsive. Low priority, data fetching or other results that updating stores. Off screen priority is something like won't visible, but to do the work in case it become visible. So these are the priority that Fiber is currently utilizing and doing the necessary updates based on this priority. This is one of the key part. So as we have seen, the main problem with Fiber is, main problem with React is it is a recursive way of processing. It holds the main thread. Whereas Fiber is, it split the work into multiple chunks, and even it will not give this multiple chunk directly to main thread. It will wait for main thread to free. At the time, it will give the chunk of work with the priority. That is one of the key advantage. So using this, you can see how the differences between the stack reconciliation and Fiber reconciliation. The main thread will get free, do whatever task it needs to do. After that, it will get the task from the React, and it will the React Fiber, and it will do the necessary updates. So in this case, it will not block the main thread, and it will do the necessary task in parallel. So basically, how this happens? It as we have seen, it flattened the component tree into a linked list of Fiber nodes, which is faster, and then committing these changes into a DOM. So basically what we are doing is we are prioritizing the update and doing high priority ones first. Using this, we'll never block main thread, and based on its availability, we can complete the remaining work in an asynchronous manner. So this is one of the main advantages. So main thread will be free and it will not get blocked. It can do whatever task whenever it got a time. So that is one of the main advantage. So during this phase, as we have seen two main phases, what Fiber does is it calls these hooks lifecycle methods, which is used for the reconcile phase, and commit phase, it calls these lifecycle hosts. So using this, it's doing certain updates, as we are aware of what will happen in this particular life cycle. So I'm not going to explain that. So as we are now aware of how fiber is processing in elements, and how fiber is processing that, I mean, walking through the elements, processed elements using linked list. And we are now aware of what is work in progress tree, how the update is happening, and we are now aware of reconcile and commit, what it does. Reconcile is something building a work in progress tree in memory using linked list, whereas commit phase is only doing the changes directly on the DOM, like applying the changes that was computed on the work in progress tree, which is fleshing those changes directly into a DOM. So we are now aware of, React Fiber is not only doing this reconciliation, it also does one more additional things. Basically what it does is it manipulates a single thread process to enable asynchronous behavior. So you can see JavaScript, as we are aware, like JavaScript is a single thread process, but Fiber helps fake a multi-thread process because it's enable asynchronous behavior. I'll show that in the demo part, which you can see it. So we used to call this as a cooperative multitasking. Cooperative multitasking is something like a single process yield control periodically or when logically blocked, in order to enable multiple applications to run concurrently. So using this one process, we can get a control, and we can block the particular process, and we can do the update whenever we need. So using one thread, we can handle multiple application, multiple tasks in an application. So where you can say like one thread you can utilize for multiple work. So this is the key part. What makes Fiber much more interesting? So first thing, it makes application much more fluid and responsive. In future, it could parallelize work. I believe everyone is aware of time slicing and suspense. So basically suspense is something like it would improve the startup time while rendering components. So let's jump into the small demo for this. I have a problem, sorry. Yes, sorry. So are you able to see my screen? Sorry.
Yeah, I can. Yeah.
Sorry. Yeah. So here you can see, this is an example where for time slicing, like we have an input, and based on the input, you can see the chart will render. So basically there are 3 chart, and each input that I entered, you can see the number of components will get increased. So in Java, in React, we have 3 different way of rendering these components. One is synchronous way, second one is debounced way, third one is asynchronous way. Synchronous way, when I enter a number of characters in a faster manner, you can see the main thread get blocked. So there is a tool that I have, which you can find out, which you can see like here. You can see if I enter fast, you can see the main thread got blocked. The red color that you're currently seeing is something like my main thread got blocked, and the behavior which you're currently seeing is not an expected UX behavior. So to overcome this, there are many ways. One is debounce way. Debounce way is something like after I entered the words, you can see that DOM will get rendered after a certain delay, after my input is completed. But this is also not a proper way, because every user wanted to see the output immediately. So we have an asynchronous way. Asynchronous way where we can, without impacting the main thread, we can do whatever update we want. But here the problem starts. The problem here is when we throttle, when we emulate the CPU speed, if we slow down the CPU, let's say 4x slower, then the problem starts. You can see, even in asynchronous way, my thread will get blocked. You can see like a red color in between. So the reason behind is, even in asynchronous way, when a device have a lower CPU consumption, we will end up like problem. We will end up a problem like blocking a main thread, which will not an expected UX behavior. So to overcome this, to overcome this only, React Fiber comes in place, which has a time slicing feature. So let me come back to the second demo. Second demo is also similar to the first one, where if you do a restart, you can, I'll enable the toolbox. So if I do restart, you can see it's getting blocked. I'm rendering two components, and while rendering in a synchronous manner, it's blocking a thread because it needs to get the data from the API, or it needs to process something. So for this, we can use a asynchronous way, but the problem is it's not blocking, but the problem is it renders one by one, where I wanted to render both at the same time. So we can use async and commit phase, which behaves like a synchronous way, but it works as in a commit phase, as we have seen reconcile and commit. So this does here, like reconciling, finding out the changes, and flushing at a single time, which without blocking the main thread. So that this is a simple example of how React does on top of this. And the second thing is, hold on, yeah, let me first quickly complete this one. Second one is suspense. The reason why we need to go first for suspense is it accesses asynchronous data from server and easily as a sync data from memory. So basically, you can see the behavior. Let me show this example as well, because you can see I have a list of movies. You can see when I tap inside the movies, you can see a loading cache, which will load me a content first, whereas review will be the second one. So when I come back to the same, it will be much more faster. This data will be served from the memory. So React have exposed the suspense. Suspense has the capability to return the data from a memory, like return the data from memory at the second time. So once the data is being stored from the memory, and also it provides an additional way where you can synchronize. One component may not block another component. You can pipeline this component rendering. You can display the component first and component second. You can pipeline the component without blocking the other component. So previously, what we do is we need to get two data. For example, in this movie, I need to get this data and this data. After getting two data only, I will render the components. So React gives the feasible way for us to overcome this. So basically, React handles these kind of synchronous way of rendering, and how to show the loading cache, etc., etc. So suspense is one of the major feature that React has released. Let me go back to the presentation now. Yes. So other than that, React also done wonderful research on top of using multiple workers. So as we have seen, currently browser has one thread. What React has does is we can even React have performed like using multiple workers. So you can see with the one worker, Fiber shown up plenty of performance differences on top of like if the page has plenty of components. Whereas if we end up like multiple workers, then the work will be divided, and the efficiency will be much more faster, which we can't imagine. Yes. So as we have seen the differences of time slicing and suspense, you can see rendering and non-blocking. The differences, like as I have shown, how this happens is it does priority-based updates and pre-render content background without showing visible content. This also will be given on top of time slicing. And suspense, asynchronous access async data from the server as easily as sync data from memory. So this is one of the major feature, and we can pass the component render without blocking siblings, as I have shown. and previously control loading states to reduce junk. I mean, precisely we can control loading states. That is also can be done using new version of suspense. This is final comparison between React and React Fiber. You can see current stack and concealer doesn't have much features. It's currently on top of synchronous model, recursive, and it has only one phase. It will block the main thread. It will give the bunch of work to the main thread. Main thread will do all the update in a single time. Whereas Fiber Reconciler, it is an asynchronous model. It's using linked list and pointers. It has two phases. One is a reconcile and commit. This reconcile phase, we will not, I mean, in this reconcile phase, main thread will not get blocked. So during this computation, main thread will do whatever it needs to be done. So once this computation has been done, then it will the updates will get flushed. So reconcile phase can be interrupted, as I mentioned. Cooperative scheduling, as we discussed previously, cooperative scheduling is one of the major feature. So basically, with one process, it else a control, and it releases periodically or when die or when logically blocked, in order to enable multiple application to run concurrently. So it has an ability to prioritize, rebase, and reuse work in progress tree, as we have seen. It has an ability to split interruptible work into chunks. It also has a time slicing and suspense to improve CPU and IO. As we have seen, CPU something like, as we are aware, like CPU will take only for creating nodes and re-rendering things, will consume more CPU power. For IO is kind of a data fetching and code splitting, as we have seen. And Fiber also has a better support for error boundaries. This is one of the major feature. The reason why I'm saying is error boundaries, which will rescue us in case of production with the malformed data or corrupted data, or data is not returned. We can use error boundaries to get a meaningful data. So the final is takeaway. The takeaway is Fiber is a single unit of React data structure that enables more complex reconciliation algorithm and cooperative scheduling. The reconciliation algorithm implemented with Fiber uses a single linked list tree traversal model. Basically, it flattened the component tree into a linked list of Fiber nodes. This is one of the this is the major change that they did to be committed to the DOM. As we have seen, the old model is synchronous recursive model that relied on browser built-in stack. The Fiber will it's something like asynchronous model with linked list and pointers. So I would strongly suggest to watch this below talk by Dan and Lynn Clark. This has much more information rather than what I've discussed. So I would strongly suggest. So the main takeaway that I would suggest for all the developers is the way that React Fiber or React team is currently thinking. So I mean, the way that it affects our daily day-to-day tasks, such as improving linked list they are using to computing the memory to reduce the memory wastage and the way it travels the tree. So we need to think a way like how we can adopt this kind of a linked list way of approaching, and cooperative scheduling, how we can utilize those kind of way into our current programming way. I mean, my suggestion would be, as a developers, we need to think like that, rather than directly utilizing the Fiber. We can directly utilize the Fiber, but the problem is, if we know this kind of information, then it is much more useful for the developers to understand. To understand, and we can improve our current day-to-day work in an efficient manner, because these are the ideas that these are the research that have been done by React for over 2 years, which we can easily utilize. So that is what I would like to say. Thank you so much for listening this. Do you have any questions?
Yeah, nice one. Thanks for that, Kannan. Yeah, really, really good. Yeah, I believe we do have a couple of questions in the Slido. I'll read a couple out. First one, everybody's anonymous. Obviously, the first question is, we have a React application which is in production. What will be the impact if we want to move to React Fiber? Is the first one.
Yes. If we are planning to move to React Fiber, then we need to check various aspects. I mean, first we need to measure our current React application that we have. So basically, if we have a less number of components, or let's say in a page I have only 2 to 3 components, then it's not necessary, not exactly necessary to move to fiber. But for future use such as time slicing and suspense, I would suggest you to go for the React Fiber, because it easily adapts, because it has a prioritized work. It can able to split the work into multiple chunks, which is much more easiest and fastest way to update the UI. So I would suggest you to check the current performance in terms of your application performance. And if you see kind of a laggy one that I have shown in the demo, like if you enter faster in the input, you can see some kind of a laggy, not a better UX, then at the time you need to think of moving to fiber. You shouldn't do it at a single shot because it's on beta. I would suggest you to try it in your local or in your integration environment to see the differences between current React and React Fiber. After that, take a decision. And I would strongly say, like, there is no changes on the API for the React Fiber. It still able to supports for the existing APIs that was exposed. I mean, all the hooks and other things will still have a support in Fiber. Only change on the internal architecture, not on the whole things.
Cool. Hopefully that answers that one. Yeah, next question. What are the things we need to consider before moving to React Fiber? In brackets, performance comparison between my old and new with Fiber.
Yeah. So I would suggest there is a feature called Profiler, which was released on top of React 16. If you use that Profiler, then using this Profiler, you will be able to understand how your component is executing, and you can see the time taken to render those components. So you can find out the exact milliseconds of those components, how it is executing using Profiler. You'll be able to find out the whole rendering time of your components, I mean the whole application. So using this, you'll be able to compare with both Fiber and your existing React application. You can do a performance metrics. So as I mentioned, you can use the Chrome developer tools, which you have currently in your browser, and you can have a Profiler that is also React have released. You can utilize to find out your performance of your components. So further doing this kind of analysis, we need to decide whether to go to Fiber or not. But Fiber has much more advantage. But once you have migrated your code and you need to do a testing, I mean performance testing in your integration environment, then only you need to decide whether we can go or not. But I would strongly suggest you to try with your current application on top of Fiber. I would strongly suggest you will be able to see the differences.
Cool. All right. Yeah, another one. So next one, I'm just checking. Yep. Next question. How does the Fiber algorithm work with functional components, i.e. class-based components with lifecycle methods to call in the reconciliation or commit stages? Do you need me to repeat that one?
Yeah, yes. So
yeah, have you got it?
Yeah. So for the functional component, so as I mentioned, like work. So it's called work. All the operation that is happening inside the Fiber, I mean, inside the components we called as work for the in terms of Fiber architecture. So it depends on class component and functional component, because functional component will return a different way of data, whereas class component, it has additional methods such as additional functionality such as lifecycle refs and other things, whereas functional component uses hooks and other things. So in the behind hood, both were different. For functional component, it will be a different way of constructing a tree. The only difference is the returning the data structure from the render method. I mean, returning the data structure. Only changes on the data structure will be differed compared to a class component. The inserting the Fiber nodes will be also differ. As I have shown, it has an additional keys for the functional components to differentiate whether this is a functional or class component. So basically, it does a different actions and different properties, which you can try it out in your local. Like you can install, maybe you can have a Fiber and you can write a functional component. You can easily, the screen captures that I have done on top of, you can see it, you can capture it in your browser itself. You can put a breakpoint and you can see the data that is being generated, and you can capture those informations.
Okay, cool. I think you may, I believe you've probably covered this, but is there any tool that you can suggest to check my application performance, React versus React Fiber? I think you may have covered that, but maybe worth
Yeah,
answering.
exactly. Yeah, good question. I mean, yeah. So as I mentioned, there are plenty of tools available in the market to analyze your performance. But there is a problem, like where if you are end up like having hybrid applications, such as not the whole page is not on top of React application, where a portion of your page is on top of React. So in that case, I would strongly suggest to go for the profiler, and you can use the dev tools. And if you have a whole page on top of React, then you can have a plenty of open source GitHub packages as well, which will exactly measure your application's performance, and it can give you an output. So the only problem is when you end up with hybrid applications, whereas the other portions on JavaScript, and you are rendering a React inside like a table or something on top of React inside your JavaScript application. So in that cases, you need to use, as I mentioned, Profiler is one of the tool that will exactly tell you which component takes which time. So I would strongly suggest to try that Profiler.
Cool. Yeah, I think this is a little bit of a different question. I think it's the last question as well. So somebody just mentions React Native and Flutter, which is better, which is the better option for mobile application. If I go for React Native, does React Fiber help in any way? Yeah.
Yeah, exactly. Even in React Fiber, so basically React Fiber React Fiber in native, correct?
Yeah. The question was React Native and Flutter, which is better option for mobile applications? If I go for React Native, does React Fiber help in any way? I don't know if that.
Yes, it does. So what I would suggest is React Native, something like I would say like Flutter has its own advantages, whereas React Native also has its own advantages. So whereas React Native is something like which is evolving, and it also has plenty of plugins or other things which is actively maintained by React. I mean Facebook team. And as you have seen, like Fiber is something like which was released. And if you, I mean, I believe native also you can utilize React Fiber, and the prioritizing an update or computing a virtual DOM, which is also similar or common for both native and React. So obviously the features that I have explained will also applicable for React Native. So only syntax may vary, but the core will remain same. So I would strongly suggest to go for React Native. Flutter, it also has its own advantage, but it depends on your application or your requirement or the way you are going to frame your application. You can choose whether Flutter or React Native. So React Native has its own styled way of doing things. You have Material UI and other things. Whereas Flutter, I'm not sure whether we have that kind of flexibility, and it is not actively, I mean, I believe native is much more actively maintained, and you can have plenty of packages that on top of native which you can directly utilize, whereas Flutter, you need to try it out, you need to find out, and yeah. So I would suggest my opinion would, I will go for React Native because it is currently evolving, and I'm getting time slicing and suspense, other features like profiler, everything I'm getting on top of Fiber. I mean, on top of React. So I would prefer native over Flutter.
Cool. Yeah, I believe that's all. That's all the questions on our end, Kannan. So yeah, well, obviously, firstly, yeah, good. Obviously, great webinar. Obviously, just want to obviously give you guys a quick shout out. Obviously, Julia and Beth for putting it together. Firstly, Kannan as well for taking the time out to actually create the actual slideshow, discuss such a pivotal topic in the dev world. And yeah, again, thanks to everybody obviously who jumped on. Hopefully you enjoyed it and learned a couple of things as well. That's the key thing. But we will be putting together a white paper and the video up on YouTube in the next couple of days. So if you guys have any feedback for us guys to improve our webinars, please let us know. And again, if you want to ask Kannan any more questions, yeah, feel free to drop him a quick message on LinkedIn. I'm sure he'll be more than happy to help out afterwards. Yeah, no, thanks again, Kannan, and obviously potentially it'd be great to get one maybe set up in the future again. So thanks for that.
Yeah, thank you so much, Jordan, for that. Thank you.
No problem. I'm just
all.
if there's any other questions. Yeah, no, that's pretty much it. Well, yeah, listen, everybody have a great evening, and yeah, thanks again for jumping on.
Thank you so much, team. Thank you so much.
All right, see you all soon. Take care. Bye bye.
Yeah, bye.